Hello my friends, welcome again to my video channel. Today we will start a new project, Kenwood TS700S Line with a transceiver. It's a VHF transceiver for 145 MHz, all mode, output is 10 watt. I don't believe that this has 10 watt, but that's another topic. External companion VFO, VFO700. This VFO is also good for split operation on different frequencies. And the companion speaker SP70. I got it on an internet auction. The seller promised that there will be optical and technical issues, and there are many issues we will see. But luckily the line is complete. I got this from a separate auction, not from the original one. I have here the complete documentation, service manual, original schematics in color, and some addendums. And also what is very important here, additional cables, microphone, power cables, AC, DC, and the connection cable for the external VFO. 2, 4, 6, the 9-pole pin for the novel socket on the rear side. So this unit is complete in every respect, but again the owner promised not working, and we will have a look at it. First I will focus of course on the transceiver itself to see what the issues are. The transceiver is optically in bad condition, dust everywhere. Here on the plexiglass the knob is spinning easily, that's good sign. It is not stuck, the grease seems to be not dried out. The knobs are moving, but they are also very extremely dirty. On the side panel, I don't know where this unit was stored. Ugly on the rear side, doesn't look better. These hairs or whatever it is, don't know. Maybe there have been some animals. This is a modification here, the two heat sinks, not original. This output here is also not, or the input, I think it's an output, it's also not original. Someone did a modification, I have to check it. This side also ugly, some corrosion, but that's not a problem. Now let's have a look into it. I will open the chassis. When we open the chassis, the top cover, inside it looks a little bit better. In the rear side here, the power amplifier, there's also some dust, but it's only on the surface. Some spider webs. Here I see a spider, one of the guys. Okay, let's take it away. But in general it looks rather good. And I will open the rest of the case. But first topic, what I have to do is cleaning inside and outside. Interesting, all crystals are supplied here. You see, this transceiver has 11 channels. There are 11 crystals. 2, 4, 6, 8, 10, 12 crystals. 12? I thought 11. 2, 4, 6, 12 crystals. Yes, there are 12 crystals. But there are only 11 channels on the front. I have to look for it, what it is. Anyhow, there are crystals equipped. I assume these crystals are good for the repeater channels also. I will check it. Relays, contacts have to be cleaned. Okay, first job is to clean it outside and inside, and then to start the test of the unit and fire it up. And now I got curious about the 12th crystal. We only have a switch for 11 crystals, and in the manual, it's the user manual where the crystals are, it is stated that 12th crystal is not available. It's not connected, so the socket has 12 slots, but only 11 crystals can be selected with the switch on the front. and the 12th one is not used, but we have 12 crystals in it, so it seems that the owner, one of the previous owners, used this place as a parking place for another crystal to swap crystals or so, don't know, but all 12 are equipped, and I assume they are for repeat operation, as I said. In the service manual it is described how to disassemble the front panel. It's very useful to see where the screws are, what has to be removed. I'm not sure whether I have to remove everything or only some part of it. This escutcheon here and the front panel, whether this frame also in the pots, I'm not sure. I think I can omit it. I only will remove these two parts here, and then I can clean it. Shouldn't be so difficult. Microphone connector, microphone socket, and so on. But first I will take away all the knobs. I removed top and bottom cover. All 8 screws were present, so the original screws, that's good. The handle, okay, has also seen better days, but it can be repaired with a needle. I have to use needles and pins. These two plastic parts here are broken off from this plunger, from this retainer. This is okay if this is broken, but this is a very, very minor topic. Not difficult. We can see again the crystals, the 12 crystals, 11 are used. Here are the 3 crystals for the 2 bands. We have 144 and 145, and the third one is for the repeater shift. It's for 144.6, that means .4. Yes, it's 600 kilohertz down from the 145 band. So this is for the repeater operation. The additional connector here has no connection inside. There was something soldered on, but it is resoldered, so don't know. And these 2 heat sinks, I don't know exactly what they are for, but I believe this is a linear power supply, the voltage regulator, which gets a little bit hot maybe. The problem is this transceiver is set to 220 volt, but there's also a 240 volt option, which is not wired, but it can be wired, so I will do it to increase the primary voltage up to 240 to reduce the heating of the power supply. But in general it looks rather good. This is the bottom cover here. We have the PA power amplifier. It is very clean. There's a counter unit. Here we have the IF part with the SSB filter. What this is seems to be the AF part, the AF amplifier. And here we have 2 crystals, maybe for SSB. Okay, the knobs are off. As you see, I corrected them in the back, and I will clean it with lukewarm water and soap. And then I will continue removing the front panel. Before I remove the front panel and the bezel to clean it, all knobs are removed. As you see, I will check the internal VFO, because it's a known problem that the VFO, which has a variable capacitor tuning, sometimes suffers with bad output. And indeed we have here also the same problem. This is the VFO frequency. It's in the range of 8 or 9 megahertz, and the problem is the amplitude. When I tune it, you see sometimes the voltage drops, and when the voltage drops too much, the display gets dark. It is blanked. This is done automatically. Here you see no output, display is blanked. When there is no frequency, the display is automatically blanked. It's an indication that the VFO or one of the crystal oscillators, or the crystal oscillators with one of the crystals, does not operate. You can see it comes back and goes back. I don't touch it. I connected the scope to the test point. The amplitude should be in the range of 300 millivolt RMS. We have in the moment 300 millivolt peak. We have 200 millivolt per division. So this is okay now. This should be more than 400 millivolt peak. That's 300 RMS. That's okay. But you see, when tuning the oscillator, it stops, and I fear we have the same problem with the external VFO. I will check it. Now we have the external VFO in operation. You see it is switched on. And also here we have the problem with bad amplitude. There are some points where the oscillation is not stable. So I strongly assume we have the same problem with this variable capacity. The capacitor has a wiper contact, and over the years, over the decades, this wiper contact gets bad and causes this problem. According to the service manual, 4 screws have to be removed. 2 on this side, 2 on this side. Do not remove the 2 screws on the bottom here and here, because they are needed to stabilize the front panel. Then it can be flipped out. There was another connection to this ground here, to the screw, which is not documented, but it's not a problem. It is easy to see, and now carefully this unit can be flipped out. And now we have access to the screws which hold the front panel and the VFO. The 2 plugs, the power supply and the coax cable for the output, have to be removed from the VFO unit. And now there are, as I see, totally 4 screws which also have to be removed. The VFO unit is out. There were 2 screws on the top and on the bottom, sorry, and 4 on the top. And 2 of these screws, 2 of these 4, were fixing the display unit, which is this one. 2 bulbs also had to be removed. 1 and the second is here. They were fixed in the VFO. Here we have the 2 holders. And now I can open the VFO and look into it, what the variable capacitor does, where the problem is. 2 screws, 1, 2, and 1 nut with a lock washer here, and then it's possible to slide off the shielding carefully, millimeter by millimeter. I don't really know what's expecting me, but I'm curious what I can see. I see nothing. Seems there are a lot of contacts inside which are grounding the shielding. You see, it's rather, now it's okay. There is a washer, I believe it was located here. Well, that's it, and here we have the variable capacitor. This is the whole electronic, the circuit. It's a coil, ceramic. It is designed to be rugged and frequency stable. It is not a PLL or any other locked circuit. It's truly an analog VFO. And I think the wiper contact, which we can see here in this position to the chassis creates a problem. I will check it and clean it. Maybe there is some dried out or hardened grease, and this should be possible to solve it. To clean this contact, I added some blotting paper, a small strip, and squeezed it between this rod and the spring. There's a spring behind, and then I can slowly rotate the tuning capacitor and clean it this way this contact. The best is to support this process with some EPA, isopropyl alcohol. You can also use a tuner spray. It's important to use a cleaner which has no residues, nothing is left, so the contact is absolutely clean, and the strip of the blotting paper can clean the contact in the best way. Normal contact cleaners are sometimes creating a thin layer to protect the contact, but this is not useful in this case. It has to be completely dry. It is brass, so I do not need any additional protective or so. And now first check. The VFO supplied with 9 volt according to the schematic. The output is connected to the scope, and we can see that when I'm tuning, that the output is stable now. I will tune the whole range. The frequency is indicated here, but it's a little bit unstable. I don't know why. This internal frequency counter isn't the best. I also set the bandwidth limit to 20 megahertz, didn't help. But we can see that the amplitude and the oscillation is stable now. So the process of cleaning this contact was successful. I also checked the strength of the spring. It is still sufficient. It's a good response of the spring when I touch it. So we don't have a weak spring. Could also be a problem of cause for the problem, but obviously it is not the problem now. And we see that the frequency varies, but with constant output now, as it should. We have success. Yes, that's the end. The next step will be some cleaning. This, which was inside the shielding, is not dirty. It's very clean, and all solder connections are okay. There are no electrolytic or tantalum caps, so I do not fear, do not expect any problem. Solder contacts, again, they look very good, as I see no problems. Only the mechanism needs some cleaning. There's some dust, and also the scale. Okay, needs some cleaning. The best is also to use some alcohol, some EPA, and you see there's a lot of dirt. The last 4 decades created a lot of dust on it, and I need it a second time. I have to be careful not to remove the black paint. Now you see dirt, dirt, dirt everywhere. I removed the meter with 1 screw as described in the manual, and there's 1 screw here. Another screw is on this side, here at this point. A 3rd screw should be there, but there is no 3rd screw. There are only 2 screws. This 3rd screw, where is it? This bezel is held by 3 screws, 1, 2 and 3, but this 3rd screw is not existing. There is no screw in. Don't know why. Forgotten in the factory. So the bezel can be taken out now. It's rather easy. And now it can be cleaned. It is dirty, dirty, dirty. Removing the front panel is rather easy. Only remove all nuts and washers. Here the switches are protected by such a felt. One is a little bit brittle. Maybe I will replace it, and then this can be taken out and cleaned together with this plastic bezel with some lukewarm water, and then we have also a good chance now to clean this outside the frame, which also looks rather dirty. I don't know exactly what it is. Dust. And then we have also access to the switches. Maybe we should clean them with some contact cleaner, because we have good access in the moment. All these switches, also the rotary switch, could be an idea. To clean the frame outside, the best was this cleaner for metal, for brass, copper, silver, gold. It's this special cleaner. It's the best one. I don't know what this dirt is. Could be nicotine. The complete transceiver was outside very sticky. It was ugly, so maybe one of the previous owners was a smoker. I'm not sure, but it looks like. Because this has a color of tar, and it cannot be cleaned with other solvents. So I'm rather sure it is nicotine, but of course I cannot prove it. Anyhow, I get rid of it now. The cleaned front panel is in place again. This bezel is also cleaned. I will install it later. The instrument, the S meter, has such a clamp. The plastic, it was a foam, a rubber foam also, was not existing after decades, so I decided to replace it by a new one. I take this black conductive foam used for protection of static devices. It is good, and I can glue it onto it. This is conductive and has the advantage that any static charge to the plastic case of the instrument is grounded via this clamp, so I think it's better for the instrument to have at least some continuity to ground to prevent static charge and any influence on the pointer, as we know, because a plastic charged plastic front of an instrument can influence the pointer. This is ugly. The front panel, the bezel and the knobs are installed now. This transceiver looks now optically rather good. Electrically there are some problems I have seen. You may ask why I started with the optical work. Well, this transceiver was so dirty, it was partially disgusting to work on it, so I decided to first clean it and then to work electrically on it. Now the first check whether the VFO is operating now. The scope is again connected to the output of the VFO. We have 200 millivolt per division, so more than 400 millivolt peak. That's what is expected, and when I tune over the range, starting with 0, then the output voltage now is stable. And I can tune over the whole range, over the whole megahertz. There's always 1 megahertz tuning range, and the band is selected with this knob. 144 or 145, can go to 144, but this doesn't matter. The VFO is not affected by this band switch. And you see the whole band now is working as it should. the frequency varies. You can see it at the end that the frequency shifts. The frequency counter I've switched on is not so good. I don't know what the problem is, but doesn't matter. We see the VFO now is working. But maybe you can see it in the picture. It is moving up and down depending upon the frequency I have chosen. I assume there is some hum on it, and I will measure now the hum of the signal. I reduce the time base to 10 milliseconds per division, and the source I check with AC line. And here you see there's some ripple on it. I will make the picture a little bit better. There's an envelope on both sides. This is an indication of hum. We have 10 milliseconds per division, and every 10 milliseconds we have a peak. This is 100 Hertz, so the 50 Hertz line, double frequency, so we have a 100 Hertz ripple on it. This is typical for 50 Hertz system, so I assume we have here a problem with the electrolytic capacitors, and I will check it. But before I do further checks, I check the transmit function, mode FM, repeat off, and we see we have output. It is nearly 20 watt. Full scale is 20 watt on this meter, but I don't know how accurate it is. But anyhow, it means that we have output in FM. And for SSB I would have to use a mic, but this is an indication that the frequency generation in general is okay, and the PA also. And now a short check of the receiver. I've set my generator to 1 microvolt, 145 megahertz, and when I tune to 145 megahertz, okay. It's in mode upper sideband. When I go to lower sideband, it is rather precise, but the indication of the S meter is complete nonsense. But that's another topic. I will check in FM. Now the generator is modulated with 1 kilohertz FM, 5 kilohertz deviation. Oops. Squash also operates, but the S meter, let's go to center indication. Oh, that's okay. It's 0. That's good. Okay, in general it looks not so bad. It was nice. I have the problem that some of the relay contacts are bad, and I'm not sure whether you can hear it, but I hear some hum in the loudspeaker. So in general we have a problem with the electrolytic caps inside. This is the end of part 1 about this transceiver TS700S. Basic functions are okay, but a lot of cleaning has to be done. Electrically cleaning all relay contacts. Maybe some plugged contacts also have to be checked. Alignment, of course. And one topic, electrolytic caps. I'm not sure what to do. I will check something, but the decision will be made in part 2. how to proceed. I fear there is some work to be done with the electrolytics. It is not so easy. This transceiver has a lot of electrolytics inside. Guess how many electrolytics this transceiver has? 20, 30, 50? No, I've checked it. 106 electrolytic capacitors. Yes, 106 electrolytic caps. To swap them all is a lot of work, but I fear it is necessary. This unit is old more than 40 years. As I told you, it was sold in 1980 as a used unit, so more than 40 years ago it was used. Maybe it is 45 years old or so, and this is an age where the electrolytics also have to be swapped. I heard some hum, as I told you, so in general something has to be done. Well, that's it again, part 1. Stay tuned, stay healthy, see you on this channel.